This is quite a tricky question, I think, and a good plan is to get a little sketch down. So I've drawn a symmetric function. It's a bit like a quartic, I think, um, just to help get the ball rolling, really. And then it's got a line of symmetry about x equals a. And then let's take a little look. So if I just pick a point here and say this is x, then this distance, of course, is x, and this distance is a. So if I then add those two together, I'm gonna get like maybe around about here for x plus a. And if I try and look at a minus x, well, I've got this blue length minus the green length. It does look like it's going to go around the same mark. So definitely not going to rule it out yet. If I take a look at 2a minus x compared to f of x, remember here's my value of f of x, then two lots of a means I'm going to be going this amount and then this amount again. And then I'm going to be going back by x, which maybe gets me to here. So it kind of looks like that point there, 2a minus x, is in the right place. But if I just do a minus x, there's no way that that would be f of x. So I can straight away rule out 3. Just now need to investigate 1 and 2 in a bit more detail. Now let's take a look at the necessary and sufficient side of things. We've ruled out 3. So if one of these statements, well, actually, it's just the first two. Let's say the first statement. If the first statement was sufficient for reflection symmetry, it's saying that it would imply it has reflection symmetry. And if it's necessary, then the symmetry is implying that f of a minus x is equal to f of a plus x. Let's take a look at the necessary one to start with. So if we have symmetry, like this red graph, then if I go the same distance in to the right or to the left, I will get the same value of the function. And that is exactly what I've done here. I've started at a and I've either added x or minus x. So that will definitely be true. It is a necessary condition. It's just whether it's sufficient. So if this is now true, do we definitely get symmetry? But we must do, because what this is saying is if you go right or left, you'll get the same value of the function, and you'll do that for all your different values. How can you ever not get symmetry? So 1 is true. And so where are we up to so far? We've said that 3 is not true. So I've already ruled out quite a few here. Not true. And I've said that 1 is true. So now it just comes down to whether the second one is true or not. So let's look at this second one. F of 2a minus x. Now, how we could write this actually is that we're starting at a, and then I'm going to the left by x minus a. So I'm minusing x minus a. That will give me f of 2a minus x. Now, if instead I went to the right by x minus a, and I would add on x minus a, and actually that would give me f of x. So the same thing is happening here. It's a little bit more cryptic, but if we start at a and add on x minus a, we get f of x. If I start at a and minus x minus a, I get to this one. I've gone the same distance. So it's the same idea as the first one. Because I'm going the same distance, then I'm going to create a symmetrical curve. And if it's symmetrical, I will get this being true. I think we could also, if we wanted to do a substitution, I could let x equal y plus a. So then f of 2a minus x would equal f of 2a minus y minus a, which would give me f of a minus y. And then f of x would become f of a plus y. So it's actually the same condition as the first one, really. I just, now done a substitution to show it. So 2 is true as well, which means our answer is going to be B. Quite tricky, but well done.